this second example is pretty similar, except that it's a cubic equation. But notice that there's a common factor of x. So we just have to remember to factor out the common factor of x before we start. Always look for a common factor before doing anything fancy as far as factoring goes. So I move the 7x over to the right because I want the leading coefficient, which is the coefficient of x cubed in this case, to be positive. And it's already positive if it's on the right. So I subtracted the 7x from both sides in a sense, right? And I got 0 greater than or equal to x cubed plus 6x squared minus 7x. Then I factored the x out, x times the quantity x squared plus 6x minus 7. And then factor that, the trinomial. So I get 0 greater than or equal to x times the quantity x plus 7 times the quantity x minus 1. If I solve the associated equation, I get the endpoints 0, minus 7, and 1. Put those on a number line. These 3 points divide the number line into 4 regions, and I have to have a test point for each region. Okay, so I just picked test points in each of the 4 regions. I picked going left to right, -8, -4, 0.5, and 2. And I want this product in the factored form, x times x plus 7 times x minus 1, to be negative according to what it says here. The smaller end is on the polynomial, right? So that means the polynomial is smaller than 0, so it's negative. So I want it to be negative, and sometimes it helps to just write out what you want to happen. I want that to be negative. So let's try -8. -8, I get a negative times a negative times a negative, right? Because this is obviously negative, -8. -8 in here gives me -1, and -8 in here gives me -9, right? So I get all 3 negatives. The product of an odd number of negatives is negative. So that's what I wanted. I wanted it to be negative. So that region is good. Now I try my -4, and I get negative. So the x is obviously negative. -4 plus 7 is positive. -4 minus 1 is negative. So you have 2 negatives. So that comes out as a positive. Product of 2 negatives is positive, which is not what I wanted. So that region will not be shaded. It will not be part of the solution set. So x equals 0.5 in between 0 and 1 here. 0.5, that's positive, and that's negative. So I get 1 negative, so that's negative, so that'll be shaded. And then x equals 2, finally, everything's positive, and so that's positive, which is not what I want. Now, some students do a number of these problems, and they get this impression that these always alternate signs, and so they don't test every single region. That's a big mistake, because it is completely false that they always change signs. We have ones where you'll have a no right next to another no, or a yes right next to another yes. So check all the regions. Okay, now I need to shade in these regions. So the region that contains -8 is the region to the left of -7. And so I need to shade that in, right? And then the other one that works is the one that contains 5, or 0.5, which is this one here. So I need to shade that in. So that's what I did there. The endpoints are solid, of course, because it's greater than or equal to the equal part. So now, writing down interval notation, always left to right, not middle out. Left to right. Left is -infinity, and that's in your solution set because it's left arrow. Well, -infinity is the boundary of your solution set. It's not actually in the solution set. So that's why it gets parentheses. So it's -infinity, comma, -7, with a square bracket on the -7. And then square bracket 1 I'm sorry, square bracket 0, comma, 1, square bracket, close square bracket, right? A union in between them. So that's my solution.